You were at your standing desk, wrapping up a pull request and checking traffic for your route home on Google Maps, when she walks into your part of the open work area. You've seen her around before. She's middle management.
Our network utilization is out of control. The ISP measures the total production traffic, and our router stats narrow it down to certain servers. NTOP pins it down to one specific process. You know what I'm going to say, right? Yeah, it's yours. This is in your hands now.
So now you just need to figure out if all this traffic is the good kind or the bad kind. Which leaves you searching for exactly which lines of code might rob you of that much-needed long weekend you had planned. Time to bring in Gumshoe. Armed with just your wits and a Gumshoe probe tucked smartly into your JVM, you start your investigation. Seems pretty easy, right? Maybe collect some data samples into a file, look at the file, spot the problem. Spot the problem. This is the part where some developers have been known to pass it off to a fall guy, an intern, or maybe that new guy. But that's not the kind of programmer your mother raised. Not you. You read the f***ing manual and figure it out. You learn that what you've collected is a little like those Russian dolls, and not the kind you gave to your niece. No, these dolls are really text files, and inside those text files are samples, taken at regular intervals. Inside those samples are all the call stacks that read or wrote to a socket, and some details. Those files are your haystack, and somewhere in there is a needle. You can look at your Russian haystack dolls with this. Each stack is a column, each row is a frame in the call stack. You can hover or click on the box to see the network traffic that resulted from that line of code. Sometimes the stacks start with the same frame at the bottom, like thread.run, see? When those frames combine into a wider bar at the bottom, we're looking at a flame graph. And sometimes the stacks wind up with the same frame up at the top, like where the socket read and write are happening. When those frames combine into a wider bar at the top, now we're looking at a root graph. Another little tip you picked up reading the manual was that if you want to do anything more useful than show off those fancy flaming root graphs of Russian haystack dolls, you have to set the width to something more sensible, like the statistic value. How about we take a look at a count of the combined read and write operations? Which stacks are performing all of those network operations? I bet you could pick these out of a lineup. Don't let this sneak up on you. Switch to bytes instead of counts, or maybe just show reads or writes. It looks like some of those stacks are heavy hitters. This haystack is looking more like a needle every minute. At least, that's how it seems from the manual. But in the real world, things can be messy. Real messy. You think back to those carefree days in the conference room, back when architecture was only scribbles on a whiteboard and network utilization was just a question the IT guy never got a chance to ask. It's all still there, somewhere in your call stack, deep inside that smelly onion of your Gumshoe samples, and you can still peel away layer after layer, wipe away the tears, throw out the Java platform classes, frameworks, third-party libraries, and leave just the bite-sized core. Hold it up to the light. That's yours. Now, you do what you have to do. You filter out the JDK and even Gumshoe itself. But you know that won't be enough. You narrow your filter to include just the packages in your project, but still, you don't stop. You even exclude some of your packages, those interceptors, some utils, some wrappers. You have a crazed gleam in your eye. Throw it out! Throw it all out! Then take a look closer at what's left. Those frames at the top are where your app is reaching out to other systems. Not the details of the JDBC drivers or HTTP calls, but big, meaningful operations on domain objects, things you can sink your teeth into. You rearrange a little. Shoo the bit players behind the curtain, just the bottom 1%, and here you have it. This is what's behind that network traffic. At least that's part of it. Then you turn the tables and look at the flame graph too. Looking across the bottom, now you see the calls made into your system and how network traffic is divided between them. You finally have your needles from those Russian haystack onions. Go ahead and bask in it. You've earned it. And while you're enjoying that long weekend, you can relax and think back fondly of this screencast and remember how Gumshoe solved all your problems.
Okay, that's good. I'm glad you found the problem, but when are you going to fix it? Hey, are you there? Did you leave?